I didn't forget them.
They're actually on my bed.
Why are they on your bed? You like can crush them if they're on your bed.
No, they're in a case and I forgot them. They were supposed to be in my backpack. I thought it from.
Why don't you wear them all the time?
Well, I should.
If you wear them all the time, you actually get used to them, and it's you actually don't feel good when you don't have them on. You're trying to be like, I don't think I look cool or pretty or insert whatever your fucking opinion is here, and so you don't wear your glasses. Why do you not wear your glasses then?
Bad memory.
There's no. If you put them on when you wake up, they don't like to come off your face without you doing it. There's no forgetting them. You put it on your alarm clock. You put it your phone. You put your glasses on top of your fucking cell phone when you go to sleep, so that when you get up, you gotta put them on before you get to the phone.
It's because they're only for reading. They're only for.
Oh, they are.
Yeah, so it's not like.
That's clearly not true because you need them to see a giant ass fucking screen of mirror. This is all being recorded. I should have led with this before we start recording. Let's do some math.
My case.
Someone lied to you about them being only for reading. I know that.
No, for real, they are for reading.
Really? We're calling this reading? Reading is like small ass text, like. This is not reading. This is like looking at the art on the wall. It's gorgeous. It's beautiful art. We were in chapter 11 and we were talking about algebra stuff. And so we're going to hit 11.3. And 11.3 is doing some basic operations with polynomials.
Was there any extra credit?
Read the syllabus.
All right.
I'll show you the syllabus later. It's in the syllabus. It's called doing your homework. If you do your homework, it's called leveling up. I'm a gamer. I instituted gaming policy in my syllabus. If you do a certain percentage of your homework, you level up, you get bonus credit on your exams. There you go. But if you want the details, you're going to have to go look at it. All right, so basic operations of polynomials. It's important to get some vocabulary out. What is a like term? So like terms. They have the same variables with the same exponents. There we go, a little bit better. Same variables with the same exponents. So for example, (3a squared b) and negative 2/3 a squared b are like terms. They both have an a squared and they both have a single b. (5x cubed y squared) and negative 3x squared y cubed are not. They both have x and y, but this one has x cubed, this one has x squared, and the exponents are different. So the exponents don't match, and that's what's causing it to be not a like term. Sometimes it's not immediately clear whether or not something is a like term or not. If we have something like 2ab squared and negative 5a squared b squared, just looking at them, I'm off the screen because zoom mode. I didn't zoom out. I told her I was going to zoom out and I didn't zoom out. She's like, yeah, mock me. I can see you read everything just fine. See, they don't look the same by casual inspection. But if I apply this square here to everything, I have 4a squared b squared. And now my a squared and my b squared match my a squared and b squared there. So these are like terms. If terms are like, if two terms are like terms, they can be combined through addition and subtraction. I'm off the screen again. By adding or subtracting the coefficients. Or the numbers in front. I know it's a lot of text. We'll do some examples with actual stuff in a second.
I think most of the homework is combining like terms.
Yeah. There should be some multiplying in there too.
Why did I think that we already done something?
Maybe because you already knew that, understood fundamentally how that combining new terms. You guys ready for more? Ariana's pencil's moving. I don't know if are you writing this? I'll wait. Go ahead. Are you done writing it? Did you get everything that you wanted written? So I just happened to ask right exactly as you're finishing. Okay. So if I've got 5x cubed and I'm going to add 2x cubed. What we can do is I can treat this as 5 plus 2x cubed. And I get 7x cubed. Some students get hung up on the letters being in there and go, I don't understand what's going on. But if I said the same thing using apples, and I said 5 apples plus 2 apples, you would all be able to tell me relatively quickly that that is 7 apples. It's the same idea. Just because it's got variables in it, don't let it trick you. We're adding 2 items that are identical. So let's go through some examples. Let's give you some stuff to try. Why don't you guys try doing y to the 4th minus 3y to the 4th? What do I have in front of it? What? How many y? What's going on here? What's with the first one? What number can I use with that? I can use a 1, right? This is like 1 minus 3 y to the 4th. And 1 minus 3 is -2. That's it. So if you don't see a number, put in a 1. This is something we also do in English. No one says I ate 1 apple. Say I ate an apple. When there's only 1 of something, we don't use the number. It's assumed by the lack of a number that there's only 1. All right, let me give you some more. Bertha brought to my attention chapter 11 was due tonight. It's been changed to the Wednesday after spring break.
Chapter 11?
Yeah, the one we're doing right now. So the homework has been extended. Because we weren't ready for it. I just got behind. I've been taking longer to teach the stuff to make sure you all get it, covering less than I wanted to. I had a very ambitious schedule set when I started the semester. And I realized some of these topics are going to take more than fucking 45 minutes to talk about. What? What does this turn into?
7A plus 1.
Or just 7A plus B? Did anyone else get something different? We look at, we got 2 A's, the 3 plus 4 go together. And I've got for B's -2 plus 3. So yeah, 7A plus 1B is correct. I need to get me some mirrored glasses. Like his glasses. I need some fucking mirrored glasses so you can't see my eyes.
Yeah,
So the
yeah, I guess.
sunglasses that go like all the way around.
Right.
So,
But then you can't see my eyes, and then I'm just like, what is he looking at? Is he looking at me? Quit fucking looking at me, Jones. What do I get here? What?
The X is 1.
The X is 1.
Or X3 plus. I don't know.
Okay, so does this X to the 3rd go with anything here? No, so it's gonna say the same. Does this 3x squared go with anything over here? Yeah,
Minus.
it goes with a -5, right? So 3 minus 5 is -2. And I only have one thing left. I've got the 2x to the 4th. And we talked about writing them in descending order the other day. So I'm going to rearrange this and put the x to the 4th in front. What about this? What does that parentheses do here?
Like the negative.
I gotta multiply or distribute that negative throughout, yeah. So I got a little, like the last one, the plus doesn't change anything, but here the minus definitely needs to be distributed. And it's gonna change the sign of whatever's on the inside. So if it helps, rewrite that part like that. What do we have now? It's the final.
Minus 2y squared plus 3.
It's 2y squared plus 3y. All right. All right, all right, all right. All right, let's, it's still big or go home. I've got 2n to the fourth minus 4n cubed minus 2n minus parentheses 5n to the fourth minus 3n cubed minus n squared plus 4n minus 5.
It's 5 and 4.
5n to the fourth, yes. With all that's going on there, you really should rewrite this without the parentheses at the end. And just hit one at a time. Changing the sign of what's on the inside. So positive 5 becomes negative 5. Negative 3 becomes positive 3. Negative 1 becomes positive 1. Positive 4 becomes negative 4. Negative 5 becomes positive 5. And now we're set up to combine them. And there's a lot going on. So I would recommend that you like mark them somehow when you've done them. That way you don't miss any. Easiest thing to do is like underline them. If I start with the highest exponent, it shows up twice. So I've got 2 minus 5 is negative 3. Next highest exponent is 3. I've got negative 4n cubed plus 3n cubed. I got negative 1, right? Or just negative n cubed. The next one is n squared, and it only shows up once. So it stays identical to what it was. The next one down is just n. It shows up twice. We've got negative 2n and negative 4n. It's negative 6n. And finally, I have a plus 5 left. Underlining it as you go will make sure you don't miss it. I've had in graduate school mathematics a thing that took up like literally 4 lines. And it was like looking at shit like this. Where it's like looking at them, you're like, fuck, there's a 4, there's a 3, there's a 2, what's? And literally like 4 or 5 lines on the page, small writing. I'm writing kind of big, so because I'm up on the screen. So literally like 50 things there without underlining, there's no way to do it. But it works pretty well with stuff like this as well. All right. So the adding and subtracting of polynomials isn't too bad. Multiplying of polynomials doesn't have to be bad either if we go about it strategically. We'll start off simple. 5y times 3y squared. We did stuff like this on Monday with just adding the exponents, right? If we had y's, we could add the exponents when they're multiplied like this. I still have the 5 times the 3. And then I have y times y squared. And the y, although it doesn't show it, has a 1 as the exponent. And then the 5 times 3 multiplies normally. 5 times 3 is 15. Or the y, when we have them side by side like that, we add the exponents. And we get 15y cubed. With practice, you completely bypass all of this crap and go directly over to that. If you need to write it out to see it for a while, do so. I'd rather you write more and get it right than try to rush it and not get shit and not understand it. All right, let me give you guys a couple. That's a cube right there. So what do we get here? What's the? This should be negative. Don't miss the negative.
Yeah, negative 18x 2 plus 3,
What is 2 plus 3?
and it's 5. But it's not like to the 5th power, or how do you?
It's to the 5th power, yes. So
See that right?
it's to the 5th power.
Gotcha.
Because you spoke quietly because you were not confident with what you were saying and I couldn't hear you. That's why I said, huh? Huh means I didn't hear you. Like, say it again. Speak confidently. Say it with pride. I know what the hell I'm doing. I know, Mr. Jones, what 2 plus 3 is. I can do this. So if it's something beside the 2 or 3 up here, we say it like this. Like a 4 would be 4th. A 6 would be 6th. If it's a 2, we say squared. We could say to the 2nd power, but that takes longer to say than squared. And the idea comes from the area of a square. A square that has a side length of s, the area is s times s, or s to the second power. And so we say squared because it comes from the area of the square. The same premise happens with cubed. X to the third power, we say cubed. It comes from the volume of a cube that has a height, width, and length of s. The volume is s times s times s, which is s to the third power. This is a cube, so we have shortcutted it to saying cubed. We don't have four-dimensional figures, so we stopped at that shape. Next one. Ooh. When they're together, you just kind of have to say them together. Like xy or x squared y or what do I get for this one?
3a squared.
3a squared. Yes, excellent. So these both have no exponents, so they're both ones. And we add 1 plus 1 and get 2. And two negatives cancel out, they make a positive. And we don't need to even say the positive when there's only one thing. The default setting for our number is positive. All right, let's take it up a notch.
Can I show you something?
Sure.
Is this the same as the original one? Because right here they're multiplying the exponent.
No, that's. See, the exponent is on parentheses. We had two things side by side.
Oh, okay.
Look at what we're doing again. You'll see that they're different.
Okay.
I get confused.
It's okay. But it seems like a question, so let me do an example with it. So we'll keep going with that. Let's say I have 3x squared and I multiply it by x cubed squared like that.
Yes. So you're gonna get rid of the parentheses first.
I'm going to deal with the parentheses first, exactly. So I still have the 3x squared, but this part here becomes, I'm going to use parentheses still just to show where I'm doing. I've got the 3 times 2, which is going to be 6. So this is 3x squared times x to the 6th. Now, even if I leave it in parentheses, the exponent isn't on parentheses, so it's just basic addition here. 3x to the 8th power. We don't have to just multiply by one thing. I can have like something like a 2x on the outside, and I can multiply by something pretty big.
But just multiply for all of them.
Yeah, in fact, if it helps you, you have two options. Once you're practiced with it, you can just do them when I go through them quickly. You can also, if it helps, rewrite it like such. So the 2x I have out front is this 2x right here. And everything else, I just use the sign that was here. With practice, you don't need this step. But it's with practice. So here we're doing it, we've got 2 times 5 is 10. Each one of these x's is just basically adding 1 to the exponent on the other one. So x to the 4th goes up to x to the 5th. Then I've got 2 times 4 and it's negative, so negative 8. The x to the 3rd power goes up to the x to the 4th power. And we follow this through. And you should get that. Let me give you guys one to do. Did you guys get?
Minus 6y to the 5th minus 15y to the 4th plus 12y squared.
Excellent. All right, so now that we've got the rudimentaries of distributing something like that to a parentheses, now let's do parentheses times parentheses. If it helps, and hopefully it probably will for a while, what we're going to do is we're going to take the first one and distribute it to both of the other ones. And I can write it out like that. I could say x times x plus 2, like that. And then I could do the 4 and distribute the 4 to each of these. And I could say plus 4 times x plus 2. So the one in green comes from that one. And the one in red comes from this one. And I'm just multiplying it by the other parentheses. If I now distribute those out, I have x squared plus 2x plus 4x plus 8. Made me go a bit hungry.
What kind of car do you have?
That's a whole lot of Nanya business.
No, because I just need the police officer. And he's literally handing out tickets.
I have a faculty sticker on my car. I'm good. I appreciate looking out for me though. I've had students stop it. This, okay, though, even though she didn't ask this. I had students go, Mr. Jones, I thought you weren't here today. Why did you think that? Your car wasn't parked in your normal spot. Whoa. They know what car was mine. They started, checking the parking lot for me. My office is right near the front door. I mean, as soon as you walk in, you can see whether or not I'm here.
I'm telling you, he's literally handing out tickets.
Okay. Is anyone else worried about their car? You can go check real quick.
Because I thought I had my phone, but my phone was in the car, so I went to go see, he was just. Oh, taking pictures too.
Yeah, he has to document it.
Yeah.
Because otherwise you say, no, I
It'd
did.
be a $5 if that.
What?
So if you're like, well, you're not saying this.
If you didn't pay for parking.
No,
You don't
like-
drive here, do you? Why wouldn't you know that?
Well, I did.
Then why are you asking me?
Well,
Why would he hand me any down tickets because they don't have a parking ticket?
I wasn't sure if there was another reason.
Oh, I might. Like if you
Yeah.
parked the wrong drive, if you back in, the campus does not like it for some reason. I've seen them ticket people for backing in. It just seems asinine to me. I don't,
Like in my case, I have I call it that disabled thing and I forget to pay.
I just leave that motherfucker up all the time.
No, you can't, though. Can't be driving.
Cops don't give a shit. All right, so I'm not done. I have two terms that are like terms, so I need to combine those as well. Some of you may have learned this or seen this before as the FOIL method. FOIL stands for first, outside, inside, and last.
That's what the homework explains. Like. They didn't get it.
And so what it means for each of these. The first is the first one in each parentheses. That's the X times the X. Outside is like what's on the outside of this stuff. This X is on the outside, this 2 is on the outside. Inside represents these two. They're in the middle. So that's 4 times X. And last means doing the last of each parentheses, 4 times 2. I loved FOIL when I was growing up, learning mathematics as when I was a young whippersnapper. Just because it had a neat name, it's easy to follow. There are better ways that don't need the name, as long as it's just you're doing the same step over and over. If I have y plus 5 times 2y plus 3, this is how I would go about doing it. First off, I take the y and I multiply it by each of these. Y times 2y is 2y squared. Y times 3 is plus 3y. Then when I get to the 5, I do the 5 times the 2y. I just take it, the one thing in parentheses, multiply it by everything in the other one. 5 times 2y is 10y. I'm, rather than going to put it to the right, I'm going to line it up underneath the other thing that has a y. Five times 3 is 15. I don't have another number that's just a number, so I'll put the 15 right there. And then I can add things vertically because their like terms are stacked on top of each other. I get 2y squared plus 13y plus 15. Do another one, we'll make it even bigger. Do the bigger examples in class so that I can do the easier ones on a test. Because if you can follow and eventually understand the big ones, then the little ones are easy. I'm going to do the same thing here. I'm going to start off with the 3x. And I'm going to multiply by everything in the other parentheses. So when I do 3x times 4x squared, I get 12x cubed. When I do 3x times 2x, I get 6x squared. And when I do 3x times -3, I get negative 9x. Now I'll do the -5. -5 times 4x squared is negative 20x squared. I have an x squared right here. I'm going to put the negative 20x squared right underneath. And I did that one. -5 times 2x is negative 10x. I will line that up underneath the other one that has an x. And do negative 10x. And finally, -5 times -3 is positive 15. And I didn't have a number without an x, so I just add that at the end. By stacking them like that, I can just add vertically. 12x cubed minus 14x squared minus 19x plus 15. If you stack them vertically like that, you can avoid the need to go, did I get them all? Because you've got them all lined up underneath each other. And if you'll notice, what's matching them up is like terms are in the same column. Let me give you guys a big one to try. See if that process made sense. Yeah. Go big or go home. We're not going home. Oh, so it's a good try. Right, y'all look like you're done writing. What did you guys get? Let's hear some ideas.
I got 6x plus to the fourth plus 2.
The third power or
No.
Okay.
Minus 1. And then I put 6. But C is like 6x.
like that?
Yeah, and then a negative x plus 3.
So you took this and you multiplied it by that.
Yep.
It's a good idea, but you got to do them all. You got to multiply it by everything.
So
We'll walk through it. Does anyone else have an answer? You had the right start, but
6x to the fourth. Plus x cubed. Plus 4x squared. Minus 5x minus 3.
did anyone else get that? I don't know what the answer is. I'm gonna find out with you guys.
I got something.
What'd you get, Bertha? Let's see what you got.
6x to the fourth plus x to the third plus 5x squared plus 7x minus 3.
Okay. Did you get something different, Nate?
First one, 6x to the fourth. Minus 3x for cube. Plus 9x squared. Plus 4x cubed. Minus 2x cubed. And then I just stopped there.
Oh, okay. So you didn't finish up. Okay. Let's go through and see what I would do. So I'm gonna take the 3x squared, I'm gonna multiply it by each thing in the other parentheses. 3x squared times the 2x squared is 6x to the fourth. 3x squared times negative x is negative 3x cubed. 3x squared times 3 is plus 9x squared. So you are following the right steps. But we got more to go. Now I'm going to distribute the 2x. 2x times 2x squared is 4x cubed. I'm going to put it underneath this one. And that hit that one. And then 2x times negative x is negative 2x squared. And then 2x times 3 is 6x. And then I'm going to take the negative 1 and multiply by each one of those. But all this negative 1 does is change the sign. So 2x squared becomes negative 2x squared. Negative 1 times negative x is positive x. And negative 1 times 3 is negative 3. So when I add them up, I get that. We have a winner. Oh, he's fucking back there grinning his ass off. I love you. You buddy. You guys want another one like that?
Harder one.
Challenge accepted. Go big or go home. Ooh, ooh, ooh.
It could be other ones.
Okay, so. Be systematic. When you do it, before you start solving it, take the 5x to the fourth. Multiply it one at a time by everything else in the other line. And make a line like I did. He said harder. Was it harder or more challenging? I don't know, either way, this is what we got. This is glorious.
I knew that.
So let me put the previous problem up on the screen so you can see what I did. To kind of help as a guide. Maybe I better cover all the wrong answers. How can I do this easily? Nope. I need it smaller. There we go. Now you can see it as a guide. Well, trying it. Just sit there and look at it.
See, no, that's what confused me. So now I'm thinking 5.
Talk to me. Let me know what you think. What's going through your brain?
I know I think I'm gonna get a 2x. Cause I see 2x. So,
Okay, so just focus on one thing at a time. Take the 5x to the fourth. Go about it systematically. Hit the first one with multiplication. Write it down.
5x.
5x what? No, we add them up.
Yeah.
Yeah,
10 because of the next, right?
this is a 4, this is a 5.
Got it.
What's 9?
Yeah, but I thought you add the other x.
So it would be 5x.
Now, yeah, just do them one at a time. So your first one will be 5x to the 9th power. Then do the next one. So what's 5 times 2?
10.
What's x to the 4th times x to the 4th? We're at 8. Keep going like that.
Would that be a negative 3? Oh, yeah.
You're going to do 5 times negative 3 is what? You know what I'm going to do is I'm going to take this page. I'm going to show my college algebra students tomorrow what sissies they are. Tell my trade school students, they're taking on shit like this. Time to step up, boys and girls. And I'm going to say, if you see Ariana around, she goes by 4 Eyes. If you see Ariana around, go, hey, 4 Eyes, I see you did a good job. It's too easy with you. This is way too easy. To heckle you. Yeah, this one's gonna take you a while. Don't go quickly.
Five eggs. So 5x to the fourth and then to six eggs. Would that be 3x to the fourth since there's no?
When there's no exponent, we put a 1 up there.
Okay, now 5x to the fourth plus 3, so that would be 15x plus 4, or x to the fourth.
Yes. Exactly. So you just gotta go slowly, one at a time. Then do the negative 4x cubed, and whatever you multiply, you should get an x to the 8th when you're done with the first term. Line it up underneath the x to the 8th.
So then negative 4x would transfer to x.
We're gonna do the same thing, hit each thing one at a time. Yeah, there's a lot of steps on this one.
You gotta go like each one.
Yeah. Mhm.
Like that.
Um,
It is many, right?
We did it all weird, but yeah,
Yeah, I know,
yeah, if you're writing everything out like that, yeah,
that's my way.
that's fine. Obviously, I'm not gonna put something like this to this magnitude on the test. Then this is just like, let's push you to get it.
Well, the one that said you can watch out the people more difficult.
I love it. I'm gonna write the first row and the second row, make sure you guys are on the same page.
How do you do it? Oh, just.
I'll just do it. It's just multiplication.
It's a beautiful thing.
I'm running out of room. I'm gonna run out of room. Writing too damn big. Let me try to write this all a little bit smaller. Ridiculous. You're getting some really good practice in though. Now I'm gonna go back over it and see if I did it right. Because there's a lot of shit going on here. So 5x and 9, got it. 10x to the 8, negative 15x to the 7, negative 20 plus 30 plus 15, okay. And then we got negative 4, negative 8, 12, 16, negative 24, negative 12, okay. 3, 6, negative 9, negative 12, 18, and 9, okay. Negative 2, negative 4, positive 6, positive 8, negative 12, negative 6. All right, I'm confident with everything but the addition. Now I gotta go through and see if I added the shit correctly. That's good. That one's good. That's good. That's good. That's good. That's good. Yeah. Ah. Did you get it? Exact?
There. Yeah.
Excellent. Let everyone else finish up on this. This is a big one, but if you get it, you're doing great. You're gonna do this is gonna be easy.
Well, that's
Easy
hard.
AF. What, Nate?
I was saying the last part, I'm like, I don't know what to do, I don't know which part to add. I just copied the last part,
What do you mean the last part?
the last,
This row or the?
line. Yeah, that one.
I'm adding vertically. All the x to the fifth get added together. All the x to the fourth get added together. So maybe I'll draw some arrows going down. This is madness. Get it? Are you sure?
Yeah.
You don't want harder?
Mhm.
No, I don't want to do harder here. I want to cover other material. We'll carry on a couple more minutes and then we'll continue on. Go back to simple. What happens if I multiply those two together? Maybe I'll do this to make sure that it's clear that we're moving on to a new problem here. Multiply those out and see what we get.
To the first.
Negative 6x and negative 6x to the first are the same thing. You do the FOIL on this. You get x squared minus 16. The middle ones canceled out. Let's try it with 2x plus y times 2x minus y. Again, the middle goes away. I'm going to rewrite this both. There's a pattern here. This has an x squared and a 4 squared. These are both x's and these are both 4's. This has a 2x squared and a y squared. These both have 2 x's and these both have y's. Whenever you have two parentheses like that that are identical, other than the sign, one is positive, one is negative between them, you always get the first number squared minus the second number squared. And this is called the difference of squares.
Because there's two B's and two A's.
What?
It's because there's two B's and two A's.
Yep. Well, two A's multiplied together and two B's multiplied together, yes.
Yeah.
So each of these is a squared thing, which gives me the squared part, and difference is the outcome of subtraction. So difference of squares. So you can use that to your advantage when you see stuff like that. If I have something like 3x minus 1 times 3x plus 1. And I recognize that pattern is going on, I can jump to 9x squared minus 1, which is 3x squared like that, minus 1 squared like that. Let me let you guys try it. This was glorious. That's what we get. If I multiply that out, that's 4y squared minus 25.
Or why?
No. It's definitely a squared thing. Now, if you have the same thing, it doesn't work. They're both pluses, it's a different formula kind of thing. You might also see this as x plus 3 squared. These two are the same thing. If we multiply it out, I have x squared plus 3x plus another 3x plus 9. Which we can see is x squared plus 6x plus 9. If I write it like this, though, we might be able to recognize the pattern. X there, X here and here. 3's there, 3's here. They have this pattern in the book. I don't think it's helpful. I think it's just as easy to write it out. They will show you a plus b squared, or a plus b times a plus b is a squared plus 2ab plus b squared. And if I do the minus version, I get a squared minus 2ab plus b squared. I don't think those are particularly useful to remember. All you gotta do is multiply them, like we've been doing.
There are two examples in homework, they confuse me.
What ones?
This time.
Okay. You actually,
The book explained it.
oh, that's okay.
Yeah.
So let's look at a couple examples like this. The first example was 8x plus 4 squared. So I think it's easier to write it like this. And just multiply. 8x times 8x is 64x squared. I'm doing FOIL here. F O outside is 8x times 4 is plus 32x. Inside is going to be 4 times 8x is plus another 32x. And last is going to be 4 times 4, which is 16. So when I add these up, I get that. A little bit easier, right? So why don't you guys give 7x plus 7y squared a try? What? You want to do the same thing up here, or you can use the formula? But I think it's easier to do what we did, like just write it as, not as squared, but as 2 parentheses multiplied by each other. I think trying to use the formula here is actually harder. Is what you should get. If you watched me write it, I wrote the 2 squared things first. And then it's easy for me to go 49 plus 49 is 98. Then I wrote the 98, and then I know I needed 1 in each letter here. That's as difficult as the homework is. I'm going to show you a couple other topics that you're not going to be tested on, but I want you to have at least seen them. So if, I don't know that they pop up anywhere in trade skills. To be honest, I don't know where some of this shit pops up in trade skills, although I'm sure I could come up with stuff if I looked around. There is a formula for difference of cubes. A cubed minus b cubed. There's also one for a cubed plus b cubed. And they look really close to the same. And I would never, this isn't on the homework. So it's just worth like saying so that you know that it exists if you ever need it. You can go look it up. Equations with cubes. This is all you Google, equations with cubes. And it'll give you this. They both have A and B in parentheses, just like this. The second half is also similar. These parts are identical. That between both formulas, exact match. The way the pattern works is whatever the sign is here, that's the sign that goes in the first parentheses. And then we're going to use the exact opposite sign in the other parentheses. So this is the difference of cubes and the sum of cubes. I don't know that you're ever going to really use that, but they have it in the book, and I'm like, there's some shit in here that I really don't know where you're going to use. I'm going to spend some spring break looking over the topics that are coming up and going, are you really going to use this? Because I saw one that I was making lecture notes for from chapter 12. I don't know where you would use it. I really don't, other than it shows up on a calculator. The other thing that's not on your homework, but it might be helpful to know, is when you're dividing with polynomials. So polynomial division. This is the easiest form where I'm just dividing by a single term. You're better off writing it like this. And now you can do exponent subtraction. Because we did this on Monday. You get x plus x squared. What? Yeah, it's a fraction. Yeah, it's from the 11.1, it's in the first section, yeah. Another thing, another example. The correct way of doing this is to break this up into two fractions. I've got 20 divided by 5 is 4. And I've got x to the 4th minus 3. And when you have something on the top and the bottom that's identical, and that's all there is, they cancel out. So this would just be minus 1. And we get 4x minus 1. I thought it was worth pointing out because a lot of students do this. Do not do this. What I'm about to do in green. Do not go, there's a 5x cubed here, there's a 5x cubed here. Cancel them out like that and put a 1. That doesn't work. If you did that, you get 20x to the 4th minus 1. And that's clearly not the right answer because it does not equal that. But it's a common mistake. So you got to break up the fractions. The other thing you cannot do. You cannot break this bottom up. This x squared plus 1 is a single thing. Do not say this is x cubed over x squared plus x over 1. It doesn't work. If there's a plus sign, you got to leave it together. This is bad juju right here. The monster under the bed will come eat your siblings, your children. If you don't have any of those, the chupacabra will get you. All right, get the fuck out. We're done. We're done with this lesson. I hope you guys have a great spring break. I am home all spring break. I'm gonna be working. If you're working on homework, please do.
Study hall at your house? No.
No, not at my house, but if you guys want to meet at like a Starbucks on the weekend, I will. But don't just like not do math all spring break. It happens every semester when the week-long break comes up. People take the entire week off and then they just, even the top students just come back. If they didn't do any homework all spring break or all Thanksgiving, they come back and they just stop doing homework. They go into vacation mode and it's not time of vacation. We've only got like 4 or 5 weeks left of school after spring break. Don't stop now. And which means don't stop over spring break. At least do a little something. Okay?
Bye, thank you.
Have a good one.